Okay. So, good morning to all. I am S.T. Kumbhare, lecturer at Electronics Engineering at Government Polytechnic India. I welcome all of you to the practical session of Digital Technique and Microprocessor course. So, I hope this PDF is visible to all of you.
Yes, sir.
Okay, fine. So, we will go to the first practical. If you don't understand anything, let me know so that I will clarify at the same point of time. This is the certificate given by MSBTE. So what you have to do at the end of all practicals, you have to take a printout of this certificate and that you have to attach at the front. Okay. So only printout will be this one. Got it?
Yes, sir.
One more printout you can take or you can draw by your own. That is this content page. So it can be drawn by your own or it can be means this printout you can take by your own, but again the page numbers will be different, so that's why try to write by your own. That will be much easier, I think. And if you are taking a printout, doesn't matter, just change the page numbers. Now this is the experiment number 1. Okay, so to study we have already covered this, but once again I will cover it so that it will be in sync. So you can write down this practical name, practical number 1, to study and verify the truth table of logic gates. I think all of you have written this, right? So the first practical is to study and verify the truth table of logic gates. So we have different logic gates, for example, AND, OR, NOT, XOR, XNOR, NAND, NOR, like that. So we have to verify some of this. Let's see. So one more thing is, this is program outcome. So these are the program outcomes which are associated with this practical. So just go through it at the end, is whenever you will give time. Then competencies and practical skills which will be developed in this is, you will be able to identify the pin configuration of logic gates, and you will be test the functionality of logic gates. Two things you will be able to achieve. Then relevant course outcome which we can achieve is test the digital system, logic families, and logic gate. And practical outcome is this. Okay. So all these has significance. So you can just read it, and later on we can see it. Okay. So logic gates are of 3 types: basic gates, universal gates, and special purpose gates. So basic gates are NOT, AND, and NOR. These are only 3 basic gates. Universal gates are NAND and NOR, and special purpose gates are XOR and XNOR. These universal gates and special purpose gates are also known as derived gates. These are also known as derived gates. Now, the first practical setup is this, which is nothing but NOT gate IC7404. So this is the pin diagram of IC7404. It is of pin 14 pin IC. It is a 14 pin IC. If you observe, this is DIP package. DIP package means dual inline package. Give me a minute. DIP package means dual inline package. Why it is called as dual inline package? Because it has pins on both the side. This side also we have pin, and this side also we are having pin, and they are in single line. That's why dual inline package. This is a whole package. That's why this is called as dual inline package. So normally it is a 14. Right now this is a 14 pin IC 7404, where we are having 7 pins on one side and remaining 7 pins on another side. So this is a pin diagram of this IC 7404. Here, if you observe, pin number 14 is VCC, that is power supply. We normally connect 5-volt power supply, and pin number 7 is ground, and remaining pins has 6 NOT gates. That's why it is also called as hexa inverter. Okay, that's why this IC is also known as hexa inverter, because 6 So hexa stands for 6. Okay. And inverter, because NOT gate is also known as inverter because it inverts the input. Now if you observe, pin number 1 is the input and pin number 2 is the output. Pin number 3 is the input, pin number 4 is the output, pin number 5 is the input, pin number 6 is the output. Similarly, pin number 9 is input, pin number 8 is output, 11 is input, 10 is output, 13 is input, and 12 is output. So like this, we have different input pins and output pins. So we have to implement this circuit where we are using this first inverter. So we are going to apply input to the pin number 1 and we are going to take pin output from pin number 2. Then we have to connect a resistor and then LED which is connected to the ground, and then we have to verify this truth table. If we apply input as 0, whether the output will be 1 or not, and if we apply input as 1, whether the output will be 0 or not. So let's connect this circuit first. In order to do this practical, I'll open the tinkercad. So you can go to this Google. There you can search for tinkercad. Is this screen visible to all of you or not?
Yes, sir.
Okay,
Visible, sir.
fine. So we have to write tinkercad and this will open it. Okay, so what I will do, instead of opening over here, I will use another browser. Let me use this tinkercad. I can open this. Then it will ask for signing in. So you can click on this sign in. It will ask for which you have to use. You can use sign in with Google. Since I have already logged in as my own ID, personal ID, so it will not ask me for the user because I have already logged in. Okay, so otherwise you have to log in with your user Gmail ID. You have to enter the user ID and then you have to enter the password. Then there are multiple things: 3D design, circuits, code blocks, lessons. So we are interested in circuits. So what you will do, you will click on circuit. These are the circuits which I have already designed, but if you have not, you can click on create new circuit. Step by step procedure I will tell you. Now what I need to do, I need to implement this. In order to implement this, I'll need breadboard. So what I'm going to do, I'm going to search over here breadboard. I can use okay, different breadboards are there, bigger one, smaller one, and mini one. I can use any of this. So I'm using this small. Just click on and bring it over here. So as soon as you bring it over here, what will happen? You can zoom it. You can zoom it. So if you observe, if you just bring the means your mouse, you will observe that this vertical line is short. Okay, this vertical line is short. This vertical line is short. Here also you will find this vertical short, and here you can observe this is horizontal ground. This is horizontal, sorry, shorted. Similarly, this is horizontal shorted and this is horizontal shorted. So it is similar to breadboards which you have previously used. Now what we can do first, okay, I will open this now. What I need a IC 7404. So I'll search over here 7404. 7404. This IC is there, right? So I'll click here this and I'll place somewhere in between. Okay. Now while placing, you have to keep in mind You have to keep in mind that this IC should be across this, okay, this middle notch. Why it is so? Because this is shorted, these pins are shorted, and these pins are shorted, but this and this is not shorted. Means what will happen if you place this to this, then this and this pin will get shorted. So we don't want to short these pins, power and this input one. That's why we have to connect this to in between this notch, across this notch, so that pins on this side will not be connected to pins on this side. Every time you have to keep in mind. In practical also we will do the same thing. Now, what is the next thing is, next is we need to connect power supply and ground first. Okay, VCC and ground. So in order to connect VCC and ground, we need a power supply. So what you can do, you can search over here power supply, which you can click. What happened? Okay, let's check out power. Is not. Let's check. Here you can just search. So this is the power supply. You can click and bring it over here. After bringing it, this will give you the things. Let us say I'll say VCC or power supply, power supply, or what? Okay, and we want 5 volt as the output because our is a digital circuit. So voltage 5 sufficient, current 5 doesn't matter. Now what I will do, I'll connect this power supply VCC. Okay, this red one is VCC to the plus, this plus you can observe. So I'll connect this, and since it is a power line, I'll give the red color to this, and this I want to short with this plus also. So what I will do, I'll connect this line with this line also, and also I'll make it red, so that what will happen, whatever current will flow from here to here will be same till this. Now similarly I can connect this to ground. So this negative pin I'll connect to this. Since it is ground, I'll connect it, make it black, and same thing I will do, I'll connect this to this negative, so that this ground will flow from here to on this line. Okay, so here we have connected power supply. Next thing we have to do is we need to connect pin number 14 to VCC and pin number 7 to ground. So this is pin number 7. Look, as soon as you bring it over, it will say ground, and since this is short, I will connect here to here. This is ground. Okay, I'll make it black since it is ground. Similarly, pin number 14 is power supply, so I'll connect this to this, and then I'll make it red. Now look, one thing is that if I haven't connected this to this, then I have to connect this pin to this side, which makes the circuit more complex. So in order to make it simpler, I would like to connect this to this, so that I can connect this power pin on this side itself and ground pin on this side itself, so that no cross sectioning will happen. Okay, this is the benefit. So we have connected ground and we have connected VCC. Now the next part is we need to connect input to pin number 1. Okay, 187. Now input should be 0 or 1. 0 means what? Let's look at over here at the bottom. What you can observe, 0 means 0 volt and 1 means 5 volt. So I can do the same thing over here. Let me. So what I will do, I'll connect a switch. So I'll search switch. So 2 switches are there. I can connect this, and then I'll connect this to
हेलो
हेलो
हेलो।
सर पीसी अटक गया
नेटवर्क इशू होगा।
hello, am I audible?
यस सर नाउ यू आर ऑडिबल
Or fluctuation happened over here. Because of that, the thing is disconnected. Okay. So is this visible screen?
Yes, sir.
So what I will do? Okay. So what I will do? I will push this switch here over here. Okay. Now what I want to connect 5 volt to the pin as well as 0 volt to the pin. One of that. So this is a switch. This is a common terminal. This common terminal needs to be connected to pin number 1. Okay. And since this is a signal pin, I'll keep it green. Why I have connected to pin number 1? Because pin number 1 is connected to input. Okay, so this I have connected to pin number 1. Okay, I can give the name to this also. Okay, fine, leave it. So I have connected this to pin number 1. But this needs to be connected to either VCC or ground. So what I will do, one terminal of this I will connect it to ground. So this I can connect it to ground and I'll make it red, black, and another terminal I'll connect to VCC and I'll make it red. Now what I'm achieving with this, whenever I keep this notch on this side, it will be connected to ground. So this pin will connect to ground. Okay, so current will flow like this. And if I make it, if I switch this on this side, what will happen? This pin will get connected to this. So this VCC will come at this pin number 1. So like this, I can connect ground or VCC means 0 or 1 on the pin number 1. I think all of you clear this. Is it clear?
Yes, sir. Yes, sir.
Yes,
Okay,
sir.
fine. Next, we need to connect pin number 2 to register. So pin number 2 is this, right? So first of all, I'll bring a register over here. So this is a register. So I'll just bring it over here. Okay. What I can do, I can place somewhere here. Either I can do like this, or another way is I can rotate this also. Okay. And I want what 330 R means 330 ohm. R means 330 ohm. So I can mention over here 330. Look, with this, these strips are also changing. Okay, and as soon as I make it ohm, again you can observe the strip change. So strip change. So 330 ohm I wanted, so I made it, and I'll mention the name R1, that is register. This register pin should be connected to pin number 2. So what I will do, I'll connect a wire from this to pin register. All of you got this?
Yes, sir.
So we have connected this pin number 2 to register. Now this register second terminal should be connected to LED. So I want a LED. So I'll search LED over here. Now this is the LED. I can take this and I can connect over here, somewhere over here. Okay, let us see. Let us see. I connect this to this. Got it? This is a red LED. Now this register pin to be connected to anode of this LED. This is the anode and this is the cathode. So anode to be connected. Now if you bring the cursor to this is the anode and this is the cathode. So this resistor should be connected to anode of this pin. Look, so it is connected to anode, and this cathode, this is the cathode. This cathode should be connected to ground. So what I can do, I can connect this pin to ground and I can make it black. So like this I can connect. If you don't want this type of cross connections, you can do one more thing. What you can do, you can rotate, you can switch this. Okay. What you can do, you can rotate this. If you don't want to do like this, you can remove this also, not an issue, and you can rotate this. Okay, like this you can rotate the register, and this register can be placed like this. This also can be done. Now this is resistor connected and this is anode connected resistor, and this and cathode is connected to ground. Like this also can be done. So it depends on you how you connect the circuit. So if you want, if you think this is complicated, you can make like this also, like this also, not issue, or this also. Both are one and the same. All of you got this?
Yes, sir.
So any of this connection can be kept. So I'll keep it like this so that it will be much easier to observe and understand. Now, so here we have connected this. Now what else is left? So everything is connected. Now I need to perform the practical. How to perform the practical? Okay. So first of all, I need to know the output table. So observation table you have to open this one. All of you keep your observation table ready because I'm going to show you the observations and calculation. What I need to see, I need to see the LED status, whether it is on or off. As soon as also I need to know the output voltage. So LED status I can observe, but where is the output voltage? So in order to measure output voltage, I need a multimeter over here. So what I will do, I will connect a multimeter. So this is the multimeter which I can connect over here. Okay, one multimeter I can place over here. This is positive, this is negative. So this I can connect to ground. This positive I can connect to pin number 2. Why pin number 2? Because pin number 2 is the output pin. So I can measure voltage at this pin. Okay, so that will give me the voltage. This I can make black so that it is connected to ground. So this multimeter will give me voltage as the output. I can see this as output voltage. I can give the name as output voltage. Okay. Also, if you want to observe what is the voltage coming at this pin, what you can do, you can take another multimeter, you can place it over here, and let us say I want to see LED voltage. Then that also I can do. This ground I'll connect to ground. This pin I'll make it black, and this red is connected to this, to the anode. Okay. Why to the anode? In order to measure the voltage which is coming at this. Now let me run this. So how to run it? You can click on start simulation. As soon as you click on start simulation, what will happen? Input voltage applied as 5 volt. The current drawn by this circuit is 8.11 milliampere, and input connected is 0 since it is this notch is on this side. So input connected is 0 over here. Okay, and since you have applied at 0 input voltage, the output generated at pin number 2 is 4.64 volt. So the voltage at output. So what you can mention, input applied is 0. Output voltage generated is 4.64 volt. Okay, and LED status is on. So note it down. Here LED status is on and output voltage is 4.64 volt. Have you noted this? Have you noted this? Am I audible?
Yes, sir. Yes, sir.
LED
Yes, sir.
status on over here and output voltage 4.64 volt over here. Got it?
Yes,
Fine.
sir.
One thing all of you have to, okay, after that, if I make it 1, means if I switch this switch, look, I have switched this to 1. So now if you observe, if 1 is applied, means this 1 is applied. Okay, 5 volt is applied. LED status is what? Can anyone tell me? What is the status of LED? On or off?
Lighting.
LED is off, right? So the LED is off over here. So mention LED off over here in second row. Have you mentioned this? Yes or no?
Yes, sir.
Off. And what is the output voltage? 0. Output voltage is 0. Got it?
Yes,
Yes,
sir.
sir.
Okay. So here we have finished not practical. Here you can place dash. 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 Done? So the reading should be like this. Like this. Have you noted like this? This one.
Yes, sir.
Done?
Yes, sir.
Okay, fine. So one thing I would like to tell you is this. Now one thing you have to observe, if I make it 0, what happened? Here I am getting 4.64 volt. After that, current is flowing through resistor and it is coming to this LED input, right? Anode. But if you observe, voltage at this point is 4.64 volt and voltage at this point is 1.96 volt. So the resistor is, means the voltage across this resistor is nothing but 4.64 minus 1.96. So if I bring a calculator, 4.64 minus 1.96. So 2.64 volt, 68 volt is getting dropped across this resistor. Got this? So the voltage across this resistor is 2.68 volt. This much voltage is getting dropped. Drop means like if you have something in your hand and if you drop it, then it is a loss. So 2.68 voltage is getting lost in this resistor. All of you got this?
Yes, sir.
Yes,
Or
sir.
no? Okay, fine. So here we have finished this experiment number, means first part of experiment 1. Now I am stopping the simulation. So if, as soon as you click on stop simulation, everything will be stopped. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. So this is not means circuit. Now next I want is, so this not we have finished. Next is this NAND. Sorry, not NAND. This is AND gate. Okay, so if you observe the this IC, that is 7408. So the IC number for AND gate is 7408. This IC number you have to remember all of you. IC number for AND gate is 7408. For inverter or NOT gate is 7404. Now if you observe this IC, this is again DIP package which has 7 pin on one side, 7 pin on another side. Pin number 7 is ground, pin number 14 is VCC, and it has 4 AND gates. It has how many? 4 AND gates. As we know that AND gate has 2 input and 1 output, that's why pin number 1 and 2 becomes input to the first AND gate and pin number 3 is the output. Pin number 4, 5 are the input to another AND gate and 6 is the output pin. Pin number 9, 10 are the input to AND gate and pin number 8 is output. Pin number 12, 13 are input to AND gate and pin number 11 is the output.
Output.
Okay. Now we need to connect this circuit. So I can modify this circuit itself. So what I will do, I'll remove this IC 7404. I will remove this okay. Then if you observe this, I am going to need resistor and LED. That's why this connection I am not going to remove. Okay, this resistor and LED I am not going to remove. As well as I need to know the LED's output voltage. So that's why I'm also not removing. What I need AND gate 7408. So what I will do, I will search over here 7408. Click. Okay, before this, give me a minute. Before this, I'll just wait. This was our previous circuit. Start simulation. So if input is 1, output is LED on. If input is 0, output is LED on. And if input is 1, output is LED off. Now stop simulation. One thing is we had completed that. One thing is left, that is this resources used. So just write down resources used, what you have used. So what was given in this table, if you observe, digital multimeter, breadboard, DC power supply, all these things are mentioned. So we'll write down in the similar fashion, and that can be found from this component list. So these are the resources used. What resources you have used? You have used what?
Power supply.
Power supply you have used, 5-volt power supply. Slide
Switch.
switch you have used,
Switch.
330 ohm you have
LED.
register you have used, red LED you have used, 2 multimeter you have used, and 1 hex inverter you have used. All of you got this?
Yes, sir.
So note it down in your this table. Name of resource is this, component is the name of resource. Make, so you can use the make from, okay, make is not mentioned over here. So you can say tinkercad. Make is tinkercad over here because we are using component from the tinkercad. So make will be tinkercad. Details. For power supply, you can say 5-volt. For slide switch, dash, you can mention dash because no specification is there. Register, you can mention 330 ohm. LED, you can mention red, 5-volt. Red LED you can mention. Then multimeter, detail, 5-volt. Then or voltage you can mention. Then this inverter 740804 IC. Quantity 111121. Got it? Have you done it?
Yes.
Completed this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So let's go to the next. So now I want to draw the circuit for this AND. So what I will do, I need 7408. So I'll remove this 7404. I will remove this line. As all of you are aware how to connect the circuit. So I'm using the same thing which I have used previously. Now what I will do, I will take 7408. So this IC will bring, I'll bring and I'll connect over here. Okay. Now if you observe 7408, so pin number 14 is VCC, pin number 7 is ground. Pin number 14 is connected to VCC and pin number 7 is connected to ground. Okay. Pin number 1 I need to connect to input A. So what I can do, I can have this combination and I can connect this pin number 1 to this. Got it? Similarly, pin number 2 is
Yes,
connected
sir.
to input B. So I'll make same sort of configuration for pin input 2. So I cannot use this only because otherwise I will not be able to use, I will not be able to apply 0 1 input or 1 0 input. So what I will do, I will make such type of combination once again. How to make it? I will search for switch. I will bring this switch over here, again over here. Okay, I will connect ground to this. I will connect VCC to this, and I will connect this to pin number 2. Or we can do one thing, we will connect this and this to this. So this is input 1, this is input 2. So I have connected pin number 1 to one input, I have connected pin number 2 to another input. Now I need to connect pin number 3 to register. So I will connect this to register. Register is connected to LED and LED is connected to ground. Okay. This I can connect to pin number 3 in order to measure output voltage. So all of you got this connection? Any doubt in this? If you have, please ask. So the same circuit I am using for connecting AND gate. Do you have any question in this?
No, sir.
Okay. So now we will go to the observation table. This. In this observation table, first we have to apply 0 and 0 as input. So I will start the simulation. Now this input is connected to ground, means 0. This input is also connected to ground, means 0. So both the input are 0, 0. What is the LED status?
Off.
Off.
Off. So you can mention off over here. Here. Off. Have you did this?
Yes, sir.
And what is the output voltage?
0.
0.
0 volt. So mention 0 volt over here. Completed?
Yes, sir.
Okay. Next combination is input A should be 0, input B should be 1. So input A is already 0. Input B is needs to be 1. So I'll click this. So this becomes 1. Okay. Now what is the LED status?
Off.
Off. So here mention off. Completed?
Yes, sir.
Now output voltage. What is the output voltage?
0.
0. So mention 0 over here. Done?
Yes, sir.
Now third combination. Input should be 1 and 0. So A should be 1. So I'll make this 1 and this as 0. So 1 and 0. So if input is 1 and 0, what is the LED status?
Off.
Off. So mention off over here. Done?
Yes, sir.
And what is the output voltage over here?
0.
So mention 0 over here. 0 volt. Okay. Every time mention 0 volt means volt. You have to write down voltage unit. Okay. So 0 volt. Because output voltage is done.
Yes, sir.
Last combination is 1 1. So if I make this is already 1. If I make this one, what is the LED status? On.
On.
So this is on over here. And what is the output voltage?
4.64.
4.64 volt. So write down 4.64 volt over here. Yes. Completed. So the output status, if you observe, 0 0 0 1. Yes or no? 0 0 0 and 1. Correct? 0 0 0 and 1. Correct or no? Off 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 and on means 0 0 0 and 1. Correct?
Yes. Yes, sir.
And if you observe the this circuit diagram over here, what is the output? 0 0 0 and 1 means it is verified. Got it?
Yes, sir.
So this table is verified. Now the thing is, you have to write down this resources used. So if you observe previous resources used, you have mentioned, right?
Hmm.
Just you have to mention whatever additional thing you have added. The additional thing is slide switch equal to 2. So slide switch, whatever you have mentioned, there you have to mention quantity as 2, because other things are same, right? Yes or no?
Yes, sir.
So in slide switch you make quantity 2, okay, and in this IC you can mention 7408 also, because you can add it. So in the previous table you have to add this detail, that slide switch you have to make quantity 2, and in IC you have to also write down 7408 and quantity is 1. Yes or no? Any doubt in this? If you have any doubt, please ask, otherwise later on we have to submit it. Any doubt in this?
No, sir. No doubt.
No, sir.
Okay, fine. So here we have completed second part of this 7408. Now the next is 7432, that is XOR, OR gate, that is OR gate IC. So if you observe this pin diagram, again it is similar to your AND gate. Pin number, we have 7 pins on one side, 7 pin on another side. So this is also a DIP package. Pin number 14 is connected to VCC. Pin number 7 is connected to ground. 1 and 2 are input, 3 is output, 4, 5 are input, 6 is output, 9, 10 are input, 8 is output, 12, 13 are input, and 11 is output. So there are 4 OR gate in this. We need to verify this truth table. Okay, now this is the circuit. So if you observe this circuit, what you will find that if we just replace this previous 7408 IC with 7432, the connection remains same. Yes or no? Yes or no? If you observe this and this circuit, what you can see that this AND gate IC you need to replace with OR gate IC, and this connection will remain same. Yes or no? Just observe, see.
Yes, sir.
Yes, sir.
So we need to just replace the IC, and that will give you the 7432. So what I am going to do, I'll just stop the simulation. I will remove this IC, delete, and I'm going to press the 7432. This IC I'm going to place it over at the same place, so nothing will change. Okay. Now if you observe, this power pin 14 is connected to VCC. This is ground is connected to ground. Pin number 1 is connected to one slide switch. Pin number 2 is connected to another slide switch, and pin number 3 is connected to resistor, which is connected to anode of LED. Okay, and then which is connected to ground. So the connection is complete.
Yes, sir.
Now we will run it. So before running it, what we will do, we will go to the table. So this is the 7432 table. Now we have to connect 0 and 0. We need to connect 0 and 0. So how to connect 0 and 0? We'll run the simulation. Now if you observe, input is A is 0, input B is also 0. So both are 0, 0. And what is the LED status? And what is the output voltage?
0.
0.
So write down off 0 volt. Off 0 volt. Completed?
Yes, sir.
Next combination is what?
0, 1.
0, 1. So this is 0. This should be 1. So as soon as I make 1, what is the LED status?
On.
On. And what is the output voltage?
4.64.
Write down. On 4.64 volt. On 4.64 volt. Complete?
Yes, sir.
Next combination is
1, 0.
1, 0. So I'll make it 1. I'll make it 0. What is the LED status?
On.
And what is the voltage?
4.64.
4.64. So write down 1 on 4.64 volt. Complete.
Yes, sir.
What is the next combination?
1 1.
So this should be 1. This is already 1. What is the LED status?
Sir,
Sorry, not
Off.
this is 1 and this is also. What is the LED status?
on.
On. And what is the output voltage?
4.64.
Write down on 4.64 volt. Complete.
Yes, sir.
So what you got? Off, on means 0 1 1 1. And if we observe this table, this one, the output is 0 1 1 1 means true, right?
Yes, sir.
And what is the what should be the correction in additional in this table? The addition is you have to just add IC, right?
Yes, sir.
You have to add IC, and the number should be 74SC32. Quantity should be
1.
5. Okay, got it?
Yes, sir.
Yes.
Now the last one, this 7486. Again, if you observe this circuit, okay, again this IC is also similar to the previous one, and this circuit is also similar to the previous one. Just I have to replace this IC 7486. Yes or no?
Yes, sir.
Give me a minute. 1 बजे. ठीक. Okay, so what I will do, I will change. Okay, I'll stop the simulation. I will remove this IC and I will search for the 7486. This IC I will take and I will keep it. Now if you observe, this power pin 14 pin is connected to VCC. This ground pin number 7 is connected to ground. 1 is connected to one slide switch and 2 is connected to another slide switch. 3 is connected to resistor, which is connected to anode of LED, and cathode is connected to ground. Is this connection complete?
Yes, sir.
Now what we will do, we'll go for this table, last one. What should be the input for this? 0 0, right? So if I start simulation now, what is the input applied? Can anyone tell me?
LED
What is
status
this
of
input?
0 0.
0. What is the LED status?
Off.
Off. And what is the output voltage?
0.
0 volt. So write down off, 0 volt. Complete?
Yes.
Okay, what is the next combination?
0 1. Input.
0 1. Okay, what should I do now? What to
Second
do?
switch. Sir, second switch on.
This one or this one?
Sir, second.
This one.
Sir. Yes, sir.
On. What is
Yes,
the
sir.
LED status?
On.
On.
And what is the output voltage?
4.64.
4.64.
So write down
1.9.
on and 4.64 volt. This 1.96 is the LED voltage. Okay, so you don't have to take this. This is just for indication what is the voltage coming at LED.
Okay.
Okay, you have to consider this one because this is the voltage at output pin. This is the voltage at output pin. So this you have to consider.
Okay, sir.
What is the next combination?
1 0.
1 0. What should I do?
So first switch on and second switch off.
Okay, what is the status of first switch now?
On.
On.
Okay, is it correct or I have to click?
Yes, sir. Correct. On.
So, and what about this?
So off.
Okay, so shall I click or is it correct? Okay. What I want, this switch should be 1.
On.
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 Means this should be at which position, black or red? Huh? This switch should be which
Red.
position, black or red?
Red.
And where it right now, black or red?
Black.
It is at black, right? This
Yes,
is
sir.
this
Yes.
switch is near to black, means it is at black. If I click this becomes red.
On red.
If I click this becomes black.
On black.
Now this is 1 0. Okay, what is the LED status and what is the output voltage?
LED
LED
is on
status
and
on.
output voltage is 4.64 volt.
Right down. On 4.64 volt. What is the last combination?
1 1.
1 1. So 1 1. What is the LED status and what is the voltage?
LED is
LED
off
status
and voltage is 0.00 volt.
Off and 0.00 volt. Off and 0 volt. Off 0 volt. Completed this?
Yes, sir.
And if you observe this, what you got? Off, on, off means 0 1 1 0. If you observe the table, what you will get? 0 1 1 0 means true. Correct?
Yes, sir.
In resources used, you have to add one more thing: IC, make tinkercad, and detail 7486 IC, quantity 1. Got it?
Yes, sir.
Actual procedure followed. Whatever procedure we have followed till now, that you have to mention. What we did, we have first opened the tinkercad, then we have searched for the breadboard, then we have searched for the power supply, then we have connected the power supply. After that, we have searched for the IC. We have connected the pin number 7 and pin number 14 of the IC to the ground and power VCC. After that, we have connected input 1 and input to the input pin, okay, through the slide switch. After that, output pin is connected to register and LED. Then we have started the simulation. We have applied input and we have noted down the voltage and LED status. Got it? Can you write it down? Yes or no? Whatever you have observed just now, that thing you have to mention.
Yes,
Correct?
sir.
And precaution followed. Connection should be proper. Then result. What you can mention? We have verified the truth table of all logic gates. Okay. Then and found correct and found correct. Conclusion: AND gate, OR gate, XOR gate, NOT gate can be used for logical operation. That conclusion you can mention. Then write down voltage at logic level 0 and 1. What is the voltage at logic level 0? Can anyone tell me? Logic level 0 means what voltage?
0 voltage.
0 volt. And logic level means which voltage?
What, sir?
Logic level 1 means how much voltage?
5 voltage.
5 volt. Okay. Then list the function of pin 7 and 14 of IC 7432. What should be the pin number 7 and what should be the pin number 14? Huh? Can you tell me? 7432. This is 7432. What is pin number 7 and what is pin number 14? Tell me anyone fast. What is pin number 7?
G and D.
Huh? G and D means ground. Okay. Pin number 7 is ground and pin number 14 is
VCC.
VCC. Okay. Next, what will happen if pin 14 is connected to ground and pin 7 is connected to VCC? What will happen? Huh? What will happen? What will happen? Okay, consider that at your home you have connected cross connection, means instead of connecting this red wire to ground and ground wire to red in switch, what will happen?
Short circuit.
Short circuit will happen, right? And if short circuit happens, what will happen to the device? Whether device will be proper or damaged?
Damage.
Damage.
So what will happen to pin if pin 14 is connected to ground and pin 7 is connected to VCC?
Device is damaged.
The device get damaged.
IC will be damaged or IC gets damaged. Okay, list number of NOT gates used in IC 7404. How many NOT gates were there in 7404? Huh? How many NOT gate were there in IC 7404? This is IC 7. This is IC 7404. How many NOT gates are there? Please tell me fast. How many NOT gates are there? Can you see this diagram? How many NOT gates are there? Huh?
Six.
6 NOT gates. 1, 2, 3, 4, 5, 6.
No solar.
6 NOT gates are there. Okay, write down the name of manufacturer of digital IC used in practical. So what you will do, you will search for this IC on internet and see who is the manufacturer. Okay. Then state the need of resistor connected in series with LED. Huh? What is the need of resistor connected in series with LED? The need is like that if you don't connect resistor, the huh?
To know the connection.
Can anyone tell me? Hello? Can anyone tell me what is the need of resistor connected in series with LED?
To know whether the connection is proper or not.
No. The need of series. Okay, what happens if we directly connect LED with this IC pin? Okay, if I connect directly with this, if I don't connect this, okay, if I would like to show you, I can show you like this. Let us say I remove this resistor, I remove this, then, and I connect this to this. And if I start simulation, and look what happens. What is said?
Damage.
Huh? Damage. Broke because of current through pin
IC get damaged.
while maximum is 25. The total current through power pin is 58 while maximum is 50. And what happens to this?
It will glow.
Huh? No, what happens to this? Current through the LED is while recommended maximum, the usable lifetime of the LED may be reduced. LED will get damaged if you don't use resistor. Okay, if you don't use resistor in between, means the LED will get damaged. So the need of resistor is in series is to protect the LED by controlling the current flowing.
Passing through it.
Got it?
Yes, sir.
Yes, sir.
Yes, sir.
Need of resistor connected in series with LED is to protect LED by controlling the current flowing to the LED. Got it? Yes or no?
Yes, sir.
Yes, sir.
Yes.
So this is the basic need. And write down the value of resistor. What is the value of resistor we have used?
330
330 ohm. Okay, 330 ohm.
ohm.
So like this, you have to answer all the questions and you have to complete this practical. Next,
Okay, sir.
to study, check experiment number 2. To study and verify the truth table of universal logic gate. Okay, so this is NAND gate and NOR gate are called as universal logic gates. So the IC for NAND gate is 7400. IC for NAND gate is 7400. This is the IC. And if you observe this diagram, you will find that 7 pins on one side and 7 pins on another side, right? Pin number 7 is ground, pin number 14 is VCC, 1, 2 are the input to NAND gate, 3 is the output of NAND gate, 4, 5 are input to NAND gate, 6 are output, 8, 9, 10 are input to the NAND gate, 8 are output, 12, 13 are input to the NAND gate, and 11 is output. Got it?
Yes, sir.
Yes or no? So now we need to connect this diagram. And if you observe this diagram, this is similar to what we have connected previously. This one. Yes or no? This one. Correct?
Yes, sir.
So if you remove if you replace this 7400, the IC will means the connection will be same. So what I will do, I'll remove this IC and instead I will use 7400. Okay, I'll connect this to this. Get it? Now I need to connect pin number 1 to input A, pin number 2 to input B. So I have connected pin number 1 to input A, correct? And pin input B to pin number 2. Yes or no?
Yes.
Pin number 3 is connected to register. Pin number 3 is connected to register. Again 330 ohm. So this is having 330 ohm, which is connected to anode of LED, which is connected to anode of LED, and which cathode of LED is connected to ground. Cathode of LED is connected to ground. Hence the circuit diagram is correct. Now we need to verify this truth table. Okay, we need to verify this truth table. How to verify? This is the truth table shown. So the combination input should be 0, 0. Okay, so let's start simulation. What is the input currently?
0, 0.
What is the LED status?
On.
What is the output voltage?
4.64 volt.
So write down on 4.64 volt. On and 4.64 volt. Done?
Yes, sir.
Yes, sir.
Next, what is the next combination?
0, 1.
0, 1. So this is 0, this is 1. What is the LED status?
On.
On.
What is the voltage?
4.64.
4.64 volt.
So on 4.64 volt. Done?
Yes, sir.
What is the next combination?
1 0.
1, 0. This is 1, this is 0. What is the status?
LED on.
Is on
LED
and
on.
output is
Output
4.64.
4.64 volt.
So on 4.64 volt. What is the next?
1 1.
1 1. So this should be 1, this should be 1. Okay, what is the status?
Off.
LED is off and
LED off and
is 0.
output is 0.00.
So off 0.0 volt. Off 0 volt. Done?
Done, sir.
Hmm.
Yes.
So on, and off means 1 1 1 and 0. Let's check out. 1 1 1 and 0. Is it correct? 1 1 1 0.
Yes.
So like this practical is completed. One thing we have to do is we have to write down separate resource required for this. Okay, over here, and that resource required is this. Write down this. Done? Yes or no?
Yes, sir.
Shall we go to the next circuit?
Yes,
Yes,
sir.
sir.
Okay. Next. Next is okay. So this you have completed. Now actual procedure followed similar to the previous one. Precaution followed again same. Next is this NOR gate, that is 7402. So again, if you observe, this is the IC diagram. Pin number 1 to 7 on one side, 8 to 14 on another side. 7 is ground, 14 is VCC. Now if you observe, 2 3 are the input and 1 is output. 5 6 are the input and 4 is output. 9 8 are input and 10 is output. 11 12 are input and 13 is output. So there is a change, slight change in pin, right? Yes or no?
Yes. Yes, sir.
Now if you observe this diagram we need to implement. So pin number 2 is connect. Okay, first of all I need to replace this 7402 IC. Yes. So what I will do, I will remove this. Instead I will mention 7402 and this I will connect to here. Okay. Now this pin number 2 is connected to input A. So this input A should be connected to pin number 2. So what I will do, I will bring it to this. I will bring it to this, right? All of you got this? What I did, pin number 2 is connected to input A. Next, pin number 3 is connected to input B. So this pin number 3 is connected to input B. So I will remove this and this is connected to pin number 3. All of you got this? Yes or no? Pin number 2 to input A, pin number 3 to input B. Next is pin number 1 is connected to register. So what I will do, I will connect pin number 1 to register. Got it? Yes or no?
Yes, sir.
Then register is connected to LED and ground. Register is connected to LED and ground. Now this multimeter is removed, which needs to be connected to pin number 1 because pin number 1 is the output. Got it? Any doubt in this?
No, sir.
Okay. Now we need to see the observation. So this is the table. So input combination is 0 0. So if I run start simulation, input is 0 0. What is the output? What is the LED status and output?
4.64 volt is
LED.
output, 10 LEDs on.
So write down on 4.64 volt. Done. Yes or no?
Yes, sir.
Yes, sir.
Hmm.
Yes,
Next
sir.
combination is 0 1. So 0 and 1. What is LED status and output?
LED is off
Off.
and output is
Output
0.00.
0.0.
Off and output 0.0. 0 volt. Off 0 volt. Off and 0. What is next combination?
1 0.
1
10.
0. So 1 0. So this should be 1. This should be 0. What is the LED status and output?
LED is off
Off and
and
LED
output
is
is 0.00 volt.
Off and 0.0 0 volt. Off 0 volt. Off and 0 volt. Next
2.0.
combination,
1 and 0.
last combination 1 1. So this is 1 1. Status
LED is off and 0.00 volt is output.
off and 0 volt. Off 0 volt. Done.
Yes, sir.
So the LED status is on, off, off, off means 1 0 0 0. Cross verify this 1 0 0 0. So here 1 0 0 0 hence proved. Got it? And in observe this resource used, what you will do, you will add only one thing, IC, that is 7402. Okay, IC 7402, which is called NOR gate, quantity 1, and result, what you can say, we have verified truth table of NAND gate and NOR gate, and which is found correct. Interpretation of result, for different input configuration combinations, we are getting expected output. Conclusion, NOR gate and NAND gate can be used uh, for the logical circuit. Here, construct basic gates, NOT, AND, NOR, NAND gate, write necessary outputs. So this you have to do from the theory. In theory, we have completed this. How to generate NOT, and OR using NAND gate. So just go through the books and net, and there you will find the answer of this. Write necessary outputs, that also you have to do. List number of NOR gates used in IC 7402. So just see the above IC diagram, and there you will find how many NOR gates are there. Explain what is truth table. So this you can search on net. How many NAND gates are there in IC 7400? So again go through this IC pin diagram, and there you will find number of NAND gate. Explain why NAND realization is preferred over AND or realization. So search on net, and there you will get this. Design AND or using NOR gate. Again, from previous lectures you will get this answer. And minimum voltage needed by gate IC. So this you can search from the net. Okay, is it okay?
Yes, sir.
Any question?
Yes, sir.
No, sir.
No, sir.
No question. Okay, fine. So we'll stop over here, since it's almost 1.5 hours over, and in the next lecture, maybe next week, or by the end of this week, I will tell you about the next practical slot. There I'll complete experiment number 3 and remaining. Okay. So
Okay, sir.
what you have to do, all of you, by the end of this Saturday, okay, all of you have
Okay,
to
sir.
submit the your assignment. What I'm doing, I'm going to give me a minute. Google Classroom. I have 3i classwork. Yes. Post your practical one submission here. Instead, I'm saying post your practical 1 and 2 submission here. Okay. So what you have to mention: title, resource use, precaution followed. Also, one more thing is circuit diagram. Circuit diagrams, and truth table. Table. Whatever are there that you have to mention. Then third, you have to resource used, precaution followed. One more is what we can say before precaution followed, procedure, stepwise procedure, what you have done. Then precautions followed, observation table 6, then conclusion and uh, this recommendation. So there you can say result also first. Result. 8 is conclusion and recommendations, and 9th is practical related questions. All these things you have to mention. What I am going to do, I am going to, and you have to upload the things. Okay, you have to,
Yes,
and the
sir.
due is this Saturday, so it's second, and the time is till midnight. You have to submit this. What I'm going to do, I'm going to upload this whatever I have done. Okay, this manual I'm preparing. So the procedure is mentioned over here. So you can write down stepwise procedure from here. Also, if anyone of you wanted to perform this practical, you can follow these steps and you can do it at home. A component list is also uploaded over here. So there, from there you can take some of the things. Okay, so this file I'm uploading right now. Okay, experiment number 1, this observation table is also there. Experiment number 2 is also completed, not completed fully, partially it is completed. So you can use this. What I will do, I will do this. So you can take a help of this also. I am uploading this also for your help. File. So all of you can take a help of this. This is just for reference purpose, okay? And you have to, okay, what you can do is, those who have already submitted your assignments, they can unsubmit it and they can submit it once again. So you can have a resubmission. Okay, any query in this?
No, sir.
No, sir.
So those who have already submitted, they have to resubmit it once again on this, and those who have not, they have to complete it by Saturday.
Okay, sir.
Is it clear? Any doubt?
Yes, sir. No, sir.
No,
Okay,
sir.
so
No, sir.
I will let you know, all of you, about the next practical, and there we'll finish up the third and remaining practicals. Okay, fine then.
Okay.
All of you can leave the session now. Thank you all.